Last week was all about lines, segments, and planes. Now we're going to start touching upon angles. Different types of angles, different pairs of angles, adding them up, subtracting them. Bless you. Okay, first vocabulary term today. Array, which we should be familiar with because we've drawn array when we copied a segment. Array begins at an endpoint and infinitely goes on in one direction. That is array. Starts at an endpoint, infinitely goes on in one direction. Now, when we label array, we have to be extremely careful. So let me do this endpoint as A, and I'll put points B and C on this ray. When you guys named a line and a line segment for me, order did never matter. You could put whatever order you wanted of the points. Now it matters. When you represent a ray, the symbol is just a mini ray. The endpoint has to go first. You cannot pick any point on the ray to go first. The endpoint of the ray has to go first. After that, it's your choosing. You can put any point now on the ray. So this could be ray AB, or we could write ray AC. Remember, a lot of people were getting this confused in my first period class. When I say ray AB, it doesn't stop there. That's a what right here, guys? That's a segment, right? That's not a ray. Ray AB tells me A to B continuously going through. Ray AC, we don't stop at C, we keep going. All right, everybody good? So again, with rays, order matters. You have to put the endpoint first. Okay, opposite rays. Take a look at that definition. Collinear rays. Collinear from last week means they're on the same line. And that's what two opposite rays do. They form a line. Take a look. Let me put 3 points on here. Let me put F in the middle. Well, not the middle, but somewhere in between. G and H. Two opposite rays. They share the same endpoint. So ray FG, and I'm going to ask somebody else to give me the opposite ray to FG. FG and what are opposite rays? Remember, they share the same endpoint going on in different directions. Okay, FG and what do you got for me? Here we go. What do you got? 18. What do you got? Ray FH. Perfect. Does everyone see they're going in opposite directions and they share the same endpoint? They got to be going in those opposite directions. Questions? Okay, now I'm going to leave it over to you and your group to figure out 1, 2, 2A, and 2B. Before you go, though, on number 1, it says name all labeled rays. I don't have that much time today, so just give me 3. Just give me 3 rays. Okay, go ahead. You and your group. Let's go. Rays from you right now. 3 rays. Here we go. Number 3. 3 rays. Okay, hold on. Ray SR. I like it. Yep. TW. I like it. And ray ST. Fine. Everyone's good. Okay, name 2 opposite rays, but T has to be the endpoint. Opposite rays. Not going the same direction. Opposite rays. T's got to be the same endpoint. What do we got going on? 8. What do we got? There you go. And you may have not had TS. You might have had TR instead or TSR. Okay, same ones, opposite. Make sure they're going opposite directions. And then name another pair of opposite rays other than TW and TS now. There are another pair up here. Hopefully you found them. 2, what do we got? Nobody's got 2? Sorry, I didn't hear. S what? Yep, or SW or STW. That's fine. Any issues with rays, opposite rays? Yes.
So when you're writing the symbol for the ray, when they're opposites, do you have to make the arrows?
No. Nope. Because look, remember what we always put first? No. Oh, you meant going this way? No. No, no. Keep it to the right. Everyone good? Okay, what happens now if I put two rays together that are not opposite? We end up forming an angle. All right? We end up forming an angle. So let's draw ourselves an angle right now, freehand. And let's talk about the three different ways to properly talk to each other about an angle. We'll talk symbol and then how to write it. Okay, first way, there are three different ways. Three different ways you can name an angle. First way is by the vertex, which again, that is the intersection of the rays. It's called the vertex. What's my vertex up here? A. So I could name this angle, angle A. That's one name for it, is angle A. Or I just want you to see, because I go back and forth between an angle symbol. Sometimes I put that little arc mark through it because that's how I roll. You guys can do whatever you prefer. All right, but you're going to see different ones from me. Everyone all right? Sometimes you'll see a lowercase number or letter inside. In this case, what number's inside? 2, so I could also call this angle 2. That's a rare one right there. But just be familiar with it. It's a rare. Majority of the time, I will have you name the angle like at number 3. Three capital letters where the middle one is the vertex. Okay, 3 capital letters where the middle one is the vertex. So angle B, AC, or I could go angle CAB. Here is why I like that method the most over the other two. Please don't copy anything down. Just take a look at my diagram now. Somebody tells me, Mr. Carlino, the answer is angle A. What's the problem with that? They tell me the answer is angle A. Madeline? Which angle A are you talking about? This one has a vertex. This one right here has a vertex at A. This one has a vertex at A, and so does the big angle, vertex at A. So which one are you talking about? That's why you can never go wrong naming it with 3 letters. Does everyone see why I cannot call any angle angle A here? I got to go DAC, DAB, CAB. Yes? Okay, so better off just naming it with 3 letters. Okay, types of angles. I'm going to go through these quickly here because I'm sure you are very, very familiar. Right angle measures exactly 90 degrees. Yep. Only other thing I want to talk about here is looking at a diagram. Obviously, they're not going to put the number 90 in there for you. What symbol will be put in there for you? It'll be a little box. Yep. Just put the box in there. There you go. There's our box. How about a straight angle? Measures 180. Anybody got another geometry vocabulary term that's the same as a straight angle? That measures exactly 180 degrees. Something we've talked about already. Sammy, what was it? Line, you got it. A line is another name for a straight angle. Acute angle, what do you got for me? Acute. Bella? Okay, I'm going to just put a little bit more detail between, it is less than 90, between 0 and 90. All right, next year you guys will talk about negative angles, which are something. They do exist. But for this one, acute angle in particular, I'm going to say measures between 0 degrees and 90. Obtuse. If this one is between 0 and 90, obtuse. Between 90 and 180. Are we familiar? We've heard of these terms before back in the day. We've heard of these. Any issues? Okay. That's why I didn't want to spend too much time. I just wanted to refresh your memory because we do spend a lot of time with right angles this year anyway. Okay. Okay, we have, what were congruent segments last week? Congruent segments that had the same length. Well, we also have what's called congruent angles, angles that have the same angle measure. What I want to do is show you how to construct one now. So everyone sees your angle A on your paper. I want to construct, meaning compass straight edge, an angle that's congruent to it, but I want it to have vertex B now. Okay, so only using your compass and straight edge, we're going to try to construct that same angle over on B. First step. Anybody remember the first step to constructing a line segment? Well, before we even picked up our compass, what did we have to do? Bella?
Make a line.
Oh.
A segment.
No.
Use our straight edge to.
We did use our straight edge, but we didn't make a line. We didn't make a segment. We made a. Begins with R, ends in A. Ray, good job. I'm glad nobody said Ra. All right, good. Ray, that's what I need to do right now. So go ahead, grab your straight edge, everybody. Make a ray where your endpoint is B. Doesn't matter which direction it's going. All right, once we have our ray, now it's time for our compass to take over. You are going to put your compass on vertex A. Put your compass point on vertex A. And what you guys want to do right now is make an arc with your pencil point that goes through the angle in 2 spots, once on each ray. So it should go through 2 spots, once on each ray. It does not matter the opening of your compass right now as long as it goes through those 2 spots. So you should have something right now that looks like our angle symbol. Then you're going to go over to vertex B. You're going to put your compass point on vertex B. Do not open or close your compass. Make sure you keep that the same setting. Go over to vertex B, and you're going to make the same arc. Not the same length. It doesn't have to be the same length. Just has to intersect your ray. Okay, it doesn't need to be the same length as your original one. Just has to intersect ray B. Okay, everyone's all right. Any issues? Okay, now here comes the tougher part. Everyone can remember that step. Make an arc through, make an arc through. Now, do you see that your first arc over on angle A intersected in 2 spots? Please measure that distance between the 2 spots with your compass. No arc marks. Measure the distance between the 2 points of intersection right now. No arc marks needed. We're just measuring the distance between the 2 points of intersection. Bless you. Everyone good? Okay, now, most of you would think, hey, let's go back to vertex B. No! Big mistake. We are not going back to vertex B. We are going back to where that arc intersected the ray. That's where we're putting our compass point. Not on B, but we're going to put it where our compass intersected the ray. Oh, shoot. There we go. Let's go back. There we go. And what you want to do, you want to create an arc that intersects this one in 1 spot. And this can be done above, or you could have done it below the line, either one. Okay, so make an arc that intersects that first one. And then once you guys have that point of intersection, grab your straight edge, draw it through. Finish off the other ray. How's everyone's look, all right? Because we're not done yet. We're done with the construction, but not how to write that they're congruent. Anybody need any? We getting in angles? We're good? Okay, a lot of people always argue with me. No. The one on the right is much larger than the one on the left. They're not congruent. What does it mean to have two congruent angles? The angles will have the same measure, not the same size, the same measure. And I guarantee if we took protractors out and measured the degree measures here, they'd be the same. So the size here absolutely does not matter. Okay, how to write it, how to mark it on the diagram. Here we go. How do I write that these two angles are congruent? Name this angle. Angle A. Everyone remember the congruent symbol. Name this angle that we constructed. Angle B. All right, angle A congruent to angle B. Now we need to mark it on the diagram to say they're congruent. Remember with two segments, what did we put on the segments to say they're congruent? Hash marks. Well, we have something similar for angles, but they're not hash marks. They're what we call arc marks. Angle B congruent to angle A. We put arc marks on there. That signifies in any diagram that those two angles are congruent. Yes?
What's the name of the squiggly?
This one here?
Yeah.
Usually it's the similar sign or approximate.
Okay.
Okay, I would stay with the similar sign. Everyone all good? Constructing one. Again, you can always go on YouTube and watch this again, or if you remember on our Aspen page under Regents Review, all those videos are on there of all the constructions we're going to do, including this one. Questions before we get to the next part? Okay. Now I'm going to introduce that you know what an angle is. What about an angle bisector? Bisect sounds like what are we doing? Bisect. Bisect. You can read it too, but divided into two parts. That's what a angle bisector does. It is a ray that will divide this angle into two congruent angles, cut it in half. I am going to show you right now how to cut this angle in half using just your compass and straight edge. Okay? So let's cut, we're looking for ray AX here. So I need ray AX to cut it somewhere in half. Ready to go. We're going to do it right on here, so there's no need for an extra ray. We're not copying anything. So take your compass, put it on vertex A, and make an arc and mix it intersect twice, like we did on the last one. So put your compass on vertex A, and make an arc so it intersects that angle in two spots. All good? You have 2 points of intersection now, correct? Place your compass point on one of those points of intersection right now. Just the one. We're not measuring any opening here. Just put your compass point on one of the points of intersection. And what you are going to do, it doesn't have to be a huge arc. You're going to make another arc above your first one. They do not have to intersect, nor should they. All right? They do not have to intersect. Just make another arc above it. Hopefully you're leaving your compass the same opening here. Now go to the other point of intersection. So I made this arc from this point of intersection. Now I'm going to the other point of intersection and making a second arc, or a third arc, that intersects that second one. Nothing has to intersect your first one. The second and third arc needs to intersect from each point of intersection. And then you guys are just cruising along. Line up your straight edge with vertex A and the point of intersection. Draw me ray AX now. Ray AX. Good. Okay, ready? You drew that one through, right? Okay, so now go to either point of intersection. Okay, make one above that one. Okay, perfect. Now go to the other point of intersection. Yep. And get those two to intersect. Boom. There you go. Now line up your straight edge. Coming around here. Go ahead. Okay, you made that one first, right? Okay, so go to one of the points of intersection, make an arc above it. Does not have to intersect, but just make an arc above it. Okay, good. Come on over to the other point of intersection and get those two to intersect. Oh, you don't need to go crazy here. Just make it intersect that one.
Okay.
So you don't need to make huge arcs here.
Okay, so should I like?
Oh, no. You shouldn't be opening. You should keep this, whatever this opening was from here to here, keep it the same opening now when you go here.
Okay.
And just swing it. Okay, there you go. That's all you need because you needed these two. I don't care about the first one. It's those two that needed to intersect. Okay. So now you line up your straight edge with that point there.
Is this?
Bella, what'd you have?
Okay, so this one here.
Yep.
And point here.
Yep. And then other endpoint. I mean, other point of intersection.
I don't know where. Okay,
so you make one arc through here.
Yep.
Go to the one point of intersection, make an arc above. Other point of intersection, make another arc with the same opening of your compass.
Okay.
Okay.
So this part's wrong.
Anybody else need a little help going? Because you're not out of the woods yet on this one. And make sure, I'm hoping you have point X somewhere on there. Is everybody okay, construction-wise? Okay, it says conclude. Now that you know that AX is an angle bisector, tell me something about my diagram. AX is an angle bisector, so it's bisecting angle BAC. What can you conclude right now? Give me some kind of statement. Some kind of statement here. Let's go back to the numbers. Some kind of statement. Number 4, some kind of statement. Angle XAC. Nice job. Yes, those two angles are now congruent. Okay, perfect. Mark it on your diagram now that those two angles are congruent. All right, go ahead and mark it on your diagram with our new arc marks that say those two angles are congruent. Just a little note, try not to do this because that's really tough to tell that this arc belongs to this angle and this arc belongs to this one. Actually, it looks like you're talking about the full angle. So when you do something like that, I would try to offset your arcs. So it looks like this and that right there. Try to offset them, okay? Or do doubles. It's up to you. All right, we good? Angle bisector. Any issues? Because now we're going to do it some algebra with them. All right, let's do it. Let's get some algebra. There's my diagram. Look at the directions above. Okay, KJ and KL are opposite rays. All right. KN, everyone see ray KN? Bisects angle LKM. So locate angle LKM, follow the letters, LKM. KN is bisecting. On your diagram right now, put markings and show me what two angles you know are congruent now. After I've given you that information, mark on your diagram with arc marks what two angles are congruent. And what two angles are you marking right now? Number 7?
Angle MKN and NKL.
Everyone agree? We're good? Okay, those are the only two that are congruent. All right, let's label everything now. Angle LKM. And anybody, this is a new term here, anybody know what that little m means? Measure, yep. The measure of angle LKM is 7x minus 5. So let's locate it. LKM, 7x minus 5. I don't know how you want to label that because that's a, I did this earlier. I don't know if that helps or not. If you don't want to label it, that's fine. There you go, LKM. NKM, follow the letters, NKM, 3x plus 9. Find the value of the measure of LKM. Now, again, it seems pretty simple, but I get it. People get it confused every year. The measure of LKM, I want an actual number in degrees. Don't give me 4x plus 2. All right, when I ask for the measure of an angle, I want it in degrees, an actual number. All right, well, we need an equation. Take a look at everything that's up there right now. Any equation you think I could set up that'll find x so I can use it to find LKM? Any equation up here that I can use? Let's go to the numbers here so I can hear from everybody. Here we go. Number 7 again. Here we go.
2 parentheses
Whoa.
3x plus 9.
Fancy.
Parentheses equals 7x minus 5.
100% correct. How did he get there? Well, what'd you mark on your diagram about those two angles? They're congruent. So if that's 3x plus 9, isn't this angle 3x plus 9 as well? And if you add them together, you get LKM, which is 7x minus 5. Nice job. So let's get going. 6x plus 18 equals 7x minus 5. Go ahead, solve for x. Let's see, move 6x over. $23. And a lot of you guys did a nice job on the quiz. You just didn't settle for x. You actually answered the problem, which is what we have to do here. LKM, which was 7x minus 5. So I need to plug and chug here. So 7 times 23 minus 5 will give me an obtuse angle of 156 degrees. How's everyone look? All right, everyone's good? Questions on how we're getting that? Plug and chug, the 23, how we set up the equation. Ask now before we get to this beast of a last one. Anything? Yes.
I don't have a question on the column, but I have a question on the congruent side. So, say in one diagram you had 2 different angles that had some.
2 arcs. Yep, 2 arcs. Good question. All right, last one. These angles are still congruent. I just have different expressions now. So those angles still congruent. Those directions didn't change. But now, NKL, follow it. NKL, 7x minus 9. JKM, x plus 3. Solve for JKN. Ooh, this angle right here. All right, I still need x. Are these two angles congruent? No, so I'm not going to set them equal to each other. I got to do something, though. 7x minus 9. What other angle is 7x minus 9? MKN, because they're congruent. All right, what do you know about all 3 angles? If I add all of them up, don't I get this straight line? This straight angle, which we know measures exactly what? There you go. 7x minus 9 plus 7x minus 9 plus x plus 3. That adds up to a straight angle, which is 180. Keep it trucking now. Okay, and I believe the final answer, 98 degrees, when you end up getting it, because you got to plug it back in for 2 angles and add them together. We'll finish it here. 14. What? Calm down. I thought that was the bell. Don't you guys leave? Nope, you don't have to. Just do the assignment on the assignment sheet. But I'm just letting you know if you do want to finish it, the answer's 98.